Hello everyone, this is Dinah. I welcome you for the 5G Technology 2 lecture session. Today we are going to discuss about the network slicing concept. The network slicing in 5G is a technology that allows a single physical 5G network to be divided into multiple virtual networks like slices. Each slice is customized to meet a specific requirement of different applications or services. Before getting to that, we have to find what is high level 5G system. The high level 5G system consists of the elements of user equipment, 5G RAN, 5G core network and data network. A PDU session is established between the user equipment and data network. So this architecture shows the separated or decoupled control plane and user plane. The control plane entities are AUSF, PCF, UDM, AMF, SMF. The user plane function or entities are UPF. So that's description about the 5G high level system. The key role of AMF, it manages the registration, mobility and session management for various devices. It initial connection establishes with user equipment, authentication and authorization of the devices, handling mobility, that is handover between the cells to cell and cells to or RAN. Communication with the session management function can be established by AMF. The SMF session management function, it manages user session and IP address allocation. Next, the establishing, modifying and terminating the user session. IP address assignment and management also done by SMF. Traffic routing decision and user data handling through the UPF. SMF interfacing with AMF and UPF for session setup maintenance. The user plane function UPF forwarding data packets to or from the user equipment to the external network. It providing the traffic offloading and optimization in handling user traffic routing per the instructions from the SMF. It supporting better quality of service management for efficient data handling. The unified data management UDM storing and managing the all subscriber data. It providing the authentication and authorization based on the subscription and it providing the policy and service configuration for the user session. Interfaces with the other network functions like AMO for authentication purpose. PCF, the policy control function, making the decision based on the real-time data. It manages policy and charging the decision, communicating with the SMF, AMF and UPF to enforce these policies, and it defining network policies related to quality of service and charging. AUSF authentication server function. It is mainly responsible for managing the user equipment authentication and key management using the 5G authenticated or the key agreement. Mainly the three non-access stratum messages are involved: authentication request, authentication response and registration request. Authentication messages are set the NAS message involved authenticating user equipment to 5G G node B and the core network. The network functions are NEF and NRF. NEF network exposure function located between the 5G core network and external third party application. It is responsible for managing the external open network data. All external applications that want to access the internal data of the 5G core must pass through the network exposure function. Network repository function, it acts as a repository. It works the central registration center for all the core network component. Registration information include the network functions, type, address, service list, etc. will be uh, located in network repository function. So for the network slicing, network slice selection function is important. A network slice is an independent end-to-end logical network created on a shared physical infrastructure. Each slide has its own resources, security, quality of service, and quality of service management. So how it can work means the physical 5G infrastructure is shared using the network virtualization and the software defined networking with network function virtualization, that is NFV. The network is divided into multiple virtual slices. Each slice is optimized for the particular services or the customers. Network slice selection function. Network slicing allows the operator to create virtual isolated network optimized for specific use cases. For example, low latency for the autonomous vehicle and high bandwidth for the augmented reality, virtual reality application. So NSSF is responsible for managing the network slices within the 5G core network. It assigns a specific network slice to each user or the application based their networks. So the slice selection, slicing service based on the requirement based such as the bandwidth or latency, or based on the reliability. It communicates with other network functions like AMF and SMF to ensure that the selected slice meets the service level agreements and the network resources are allocated efficiently. So this diagram shows the concept of network slicing. So here these are all the user equipment and this is the data network. There is a PDU session established between the user equipment and the data network. Here the three PDU sessions is established and each one is assigned for the different slices, EMBB slice and MMTC slice and URLC slices. EMBB for the voice and internet, for AR/VR application, and MMTC slices allotted for logistics, agriculture, and URLLC ultra reliable low latency service required here. So this is automobile factory services is given. So here it is each slices for different applications it is assigned. It is not necessary to maintain each slices for each application. It can be modified. That you can see here. In the previous structure, this is assigned for MMTC application, but instead of the automobile, A motors and B motors are required. More URLLC services, ultra reliable low latency communication purpose, and because of that reason here one more slice is allotted for the different. This is what the network slicing. Network slice, it is an independent end-to-end logical network created on the shared physical infrastructure. Each slice has its own resources and the security, quality of service and the management. There are different type of 5G network slices for the EMBB, URLLC and MMTC. For EMBB, it requires high data rate and large bandwidth. The various applications such as 4K, 8K video streaming, augmented reality and virtual reality application, this EMBB slices are utilized. And URLLC, ultra reliable low latency communication. So very low latency applications we can choose and it must be high reliable. The applications such as autonomous vehicle, remote surgery, industrial automation, etc. The third one is the massive machine type communication. It supports millions of IoT devices to be connected with low latency. Various applications like smart cities, smart agriculture and environmental monitoring. This everything include various temperatures, different temperature sensors, moisturizing sensors and the quality control. Different sensors will be communicate each other. This figure shows network slice selection during the registration with the AMF allocation. So here the numbers 1, 2, 3, 4, 5 represent the flow of network slice selection during registration. The user equipment based on the local configuration or policy, it send the request to send the request to the G-Node B, the request such as NSSAI. That is what registration request through NSSAI. So it is consist of the G-Node B, and then G-Node B select the AM of based on 5Gs TMSI and NSSI shared by UE, and it select the default AMF. It send the registration request through N2 interface to the initial AMF. At initial AMF, it get the subscription, and subscribed NSSI will be available here. And this from initial AMF, it send the request through N22 interface to NSSF. So what are all the request, or what are all the informations available in this request is requested NSAI, subscribed NSSAI, home, PLMN and TAI will be available on this. And then from NSSAF, it gives the response to the initial AMF, what is the allowed NSAI and target AMF to communicate, that the details will be shared to initial AMF. The initial AMF then check whether it belongs to the AMF, because this assign the AMF set. It check whether that AMF status belongs to or else is it required to generate the new request, that it decide. And then it send the information to the network repository function. The network repository function give the AMF this request NRF, NF discovery and request response that will be generated, and give it back to the initial AMF. From the response received from NRF, it takes two paths. Either it can go to the target AMF, that means NRF given the target AF, and it can communicate to the from user equipment to target, you can communicate. Or else if the NRF not assign the target AMF, then it can communicate via this way. That means it sends the request, that is the response to the G-Node B, and then G-Node B take a path to assign the target AMF. Okay, first let us see here initial AMF from NRF. It is getting the reply that NRF send the AMF reallocation information to the target EMF. Once it is completed the process, then the registration acceptance response will be communicated to the G-Node B. G-Node B send the registration acceptance, so that the flow will be completed here. Okay, suppose if the NRF not assign the target AMF, it only given the response to the initial AMF, mean the option B1, that is it send the response target AMF allowed NSSAI to G-Node B. Then G-Node B send the information. Okay, so it send the information to the target EMF. So initial messages, what is the target EMF and allowed NSSAI information will be shared here, and then that information will be get back to the G-Node B. That G-Node B will communicate to the user equipment for the allocation of network slices. So this is what the network slice selection process during the registration with the AMF. This cycle is continuous. So here we have discussed what is NSSAI, that is Network Slice Selection Assistance Information, TMSI, 5G short-term mobile subscriber identity through N2 interface, N22 interface. This information will be shared. And then PLMN, public LAN mobile network and tracking area identity, API application programming interfaces, uniform resource identifier. These are all the abbreviations we have used in the previous slides. So the slice identifier consists of SST and ST. SST slice service type selection and slice differentiator. So this is the standardized one. Based on this, it sending the NAS information. So 5G applications is represented and the deployment here. Thank you.